Hello and welcome back to another Doriflow tutorial. Today I'll be using the Doriflow add-on for Blender to set up a simulation that involves liquid, solid and granular phases all interacting in one scene. If you haven't used it yet, Doriflow is a GPU-accelerated simulation tool built for Blender. You can get it at doriflow.com or superhive.com, and it's only £35 for a lifetime license, no subscriptions. Now let's dive into the setup. So we start by selecting a default cube and moving it to the origin. Set the pivot to the 3D cursor and scale it up. Then stretch it along the x-axis to form a simulation domain. Then you can go to the Physics tab, select Doriflow, and then assign this object as a domain. Next, let's create a slope for the grains to fall onto. Duplicate a domain, scale it down, especially in X direction, then enter the edit mode. Select the top edge, Ctrl B to bevel it. Then assign this object as a solid and make sure to disable the floating option so it remains fixed during the simulation. Now we will set up a granular phase using a simple cube. Just duplicate a domain again, scale it down in Z and X, position it above the slope, and assign it to be grain. Next, we need to create a floating solid to fall onto the grain and be pushed away by the fluid. So we duplicate the grain object, move it up, scale it down, and assign it to solid, and keep the floating option so that it can interact with other faces in the scene. Now let's create the liquid that will generate the wave. Duplicate the domain again, scale it in X, lift it slightly using a 3D cursor, move it far to the one side of the domain. This will allow the liquid to flow into the scene and interact with the grains and the solid. So once you are happy with the setup, you can go back to the domain, start choosing the simulation parameters. This is an SPH simulation, so the higher the resolution, the more particles you will get, which will lead to a more accurate physics. So I'm going to choose a resolution of 85 here, and then set the time step to 1. Be careful with the time steps. If it's too high, then the simulation may diverge. If it's too low, then it will be very, very slow. This is the general simulation setup. Then we can go into the liquid solver and increase the viscosity of the liquid, let's say to 0.2, and also adjust the density and the substeps if needed. You can also expand the advanced section and tweak more parameters here. Then we can go to the granular solver. You can choose the density of the grains and set the radius variation. So this defines how much your grain particle size vary. So if the particle size is 10 and your radius variation is 10%, then the grain size will range from 9 to 11 microns or millimeters. And also the grain stiffness is simply the repelling force between the grain particles. You can also define damping, friction, and how the grains interact with the domain boundary by setting a friction passing. Finally, you can even edit the rigid parameters for the solid phase. And once we've done all of that, click Compute Fluid. Now it's not working, and as you can see, there's an error of more than one domain object file. So we need to go back and check. In this case, when I duplicate the domain object to set the fluid, I forgot to set the object into fluid phase, so that's why it's creating the error. So I forgot to set it to the grain as well. This time another grain, and see how the debug message comes. Okay, so now it works, and we just wait for it to finish. So after the simulation finish, we can start to import the solid motion. The solid is keyframe frame by frame with its dynamic, so that you can see how the particle interact. Then we can also import the particles and see how the liquid pushing on both grains and the solid eventually it will carry the grains and the solid away from what we call a shore. You can also check how the grains are being dragged by an incoming fluid, and then it's flowing back out with the waves. So let's generate the mesh. Use the flow particle to mesh at the starting frame, and as you can see here, we have some radius variation within the grain as we set it to 10% initially. If the liquid mesh doesn't look quite right and you want to change the resolution, you can go to the geometry node and change the radius in here to smaller value like 0.25 and the threshold to, let's say, for 0.35, so that it filters more particles. Sometimes it will clear the cache in the time frame, so you just need to import all particles again. You can then check whether the physics are correct by playing the simulation and look for material leakage. So click on the granular phase and you might notice some grains particles penetrating into a fixed solid. So this can happen if the liquid pressure transfer into the granular phase and overcomes the repelling force between the grain and the solid. So it's usually due to a low resolution or scaling of your domains too large. To fix this, you go to the domain, granular phase, and then maybe we can increase the stiffness to 110 in this case. So this method will also work for fixing the leakage into the solids or for other phase. Then we click the compute fluid again and wait to return to the simulation. So it only takes 7 minutes, so you can run the simulation as many times as you want. So after the second run finished, you import the particles again, and this time we check for any leakage. Now you see that the grain particles no longer leak into the fixed solid. As the waves come in, it pushes the grain and the solid, and then it recedes, drags some grains and the solid back with it. So the physics looks alright to me at this point. So this has an important application in the offshore engineering, especially in studying the localized sediment transport around submerged structures. So next time you can try it by placing a light barrier in front of the wave to study how it affects the fluid motion and helps protect the shore. So once you're happy with the particle dynamics, then you can click on the mesh, convert the grains to particles again, and because we have changed some of the dynamics, so maybe it's good to go back to the geometry node to check for all the variables. Feel free to tweak some of the parameters so that you can have a realistic mesh. Okay, so for those of you who are doing engineering or research work and want to visualize the simulation scientifically, Doriflow can also provide a VTK format. For example, you can open the Paraview, go to the catch folder with the output, select all the VTK file. So now we choose grain, liquid, and all the two regions VTK. Click OK and click Apply. So now you see the simulation setup, but in the particle format. You can also visualize the particles in many different variables. So if I choose velocity in here, and then for the liquid particles also velocity, and click play, you see that the velocity, the color of the particles will change because due to its changing velocity. Okay, so once the physics checks are complete, you can then go to the render tab. Here I've set up an optics rendering with the 32 samples in the viewport and the 64 samples for the final render. Then we can try to switch to a render view. We maybe should hide a cube for domain and also a cube used for fluid and grains. So I usually add just a very simple plane to reflect some light, just so that we can visualize the phase better, and add a very small point line, just place it in the middle, and set the power to 25k this time. Okay, so now we've seen all the faces in a much better way. So for liquid mesh, you can click on DF Mesh Liquid, choose the default material. In here you can choose all sort of base color, for example, based on your preference, and probably the transmission, so how the light can easily pass through the face. Then maybe change the material of the plane. Okay, so for the grain particles, and because we replace every single point by an icosphere, you can go into the DF grain icosphere and then start to choose the material from there. You can manipulate the material of the grains. So for example, if I choose to be red and the dynamic cube to be somewhat of purple, then sometimes when you playing around with the material and other stuff, it will clean the cache of the timeline, so the particle sometimes does not move anymore. So if that happens, just simply go back to the cube, Doriflow, and then import on the particles to mesh and granular to grains. Then you start to see the full physics again. We will now be able to see how the grains flow inside the liquid, also with the solid as well. So then once we're happy with the material and the lighting and everything, let's go into the output path and click render final animation. So the normal way that I'm doing it is that I will create a render folder and then select render. It will open the render folder, and then click it again, so you can have a path in here, and click render final animation. Try to render an image, and if you're happy with the result, then we can start to render final animation. It will freeze the UI a bit, and during the render final animation, if you think that you forgot something and then you want to go back and change, just simply press escape. So it will say rendering cancelled by the user, then implement all the changes. And if you want to render from a different frame, so let's say 6, render final animation, so it will start from 6 and then 7, 8, 9, 10. So now we just wait for it to finish. With Doriflow, you can simulate fluid solid grain interactions entirely inside Blender. Fast, stable, and GPU accelerated. You can get Doriflow now at doriflow.com or superhive.com for just £35. Thanks for watching, and I'll see you in the next tutorial.